You may want to throw up your hands and go, oh my goodness, where do I start? No, look, just be patient. Go through this by balancing a chemical equation first, and then everything falls into place. Really, it's quite logical. Here's the reaction. Silver nitrate, potassium chloride, double replacement reaction. K goes with the NO3, Ag with the Cl, and here's what you get. They're all positive 1 and negative 1 charges, so they're easy to put together here. Cations before anions, and look, AgCl is a solid. It's a precipitate. The question said we want to find out how many grams of precipitate we can form if we have lots of this reacting with only 2.6 moles of this. So we call this the limiting reagent or reactant, the thing that we're limited by. That tells you how much you can actually form of a product. Now look, if we can somehow take this information here and turn it into information here, then we can find the mass here. Let's use logic. This is a 1-to-1 what ratio? Mole ratio. This says for every 1 mole here, you have 1 here. So for every 2.6 moles here, how many can you form there? Yeah, 2.6. And so, hey, if you know the moles of silver chloride, can you find the mass? The molar mass. All of this can be done in one calculation sentence where we use dimensional analysis and unit cancellation. So this is how we do it. 2.6 moles of KCl. All right, we don't want moles of KCl, we want moles of silver chloride, but this is a mole ratio, so it's perfect. We get rid of the moles of KCl, and we want to keep moles of AgCl. And you're saying, well, this is kind of a redundant step because it's just a 1-to-1 ratio, so it's 1-to-1. You still got to do it. You still got to make sure this cancels properly, so that's necessary. I don't want to do that. You do it. Now that the moles of KCl cancel, we've got moles of silver chloride, but we don't want that. We want the mass of the silver chloride. We want mass of AgCl. We want the moles of AgCl to cancel out. What's the molar mass of AgCl? We look it up on the periodic table. 1 Ag and 1 Cl, and you get 143.32. 143.32 grams every time you have a mole. Look at what we just did. This stoichiometry, and that's what it's called, stoichiometry, this cancels out here, cancels out moles of AgCl here and here to leave us with an answer of grams of AgCl, which is what we want. And that mass is 372.632. 372.632 grams of AgCl, but you know as well as I do, you can't keep that. You've got 2 significant digits here. By the way, these are infinite numbers of significant digits. Exact numbers have an infinite number of significant digits. This has 5, and exactly 1 mole, so that's infinite again. Keep the least number, 2. So, how do you keep 2? 372.632. Oh. 1, 2. 3.72632 times 10 to the positive, because we're making this number small, so we have to make the power of 10 large. But look at 2 significant digits, 3.7 times 10 squared grams of AgCl. There's your answer. Follow along with that again. You can review it, look at it, and make sure that you understand this mole-to-mole ratio in the equation and how that translates here into doing stoichiometry.